Hello, here in this video we're going to look at pages 4 and 5 of the factoring packet. So page 4, it's going to be the more complicated type of factoring where A isn't 1, but there's going to be a GCF for all of these except number 6. So what that means in terms of there being a GCF is the first step is you're going to look and decide what number can I divide them all by. In this case, it's 2. All of those are divisible by 2. So I'm going to divide them all by 2. And then what remains is what I'm going to need to factor. So I still need to factor this piece. So I keep that 2 that I GCF'd out front. The remaining portions are going to be me focusing in on just that red underlined portion where I know it has to start off as 2x and x. And then I'm looking for factors of 1, which are just 1 and 1. I see based off the signs that I will need double positive. And then this one, since it's 1 and 1, this is our only option. Remember, you can check this by FOIL. Now I know that this gets me 2x squared. Know that this gets me 1. So I just need to check for that middle piece of 3x. And when I do this, I get a 2x. When I do this one, I get plus an x, which gives me that 3x. So I know that this answer here is correct. All right, and that's how all of these work. You're going to have a GCF, but there will still be an A value left over. So this one, for example, would be 10. They're all divisible by 10. So we had 3y squared plus 1y minus 2. Still need to factor this part. Don't forget to keep that 10 on the outside. So I know it has to start off 3y and y. And then this one has to be 1 and 2, where one of them has to be negative. So I need to have a 1 and a 2, where one of them is going to be negative. And when you try the different combinations, you'll see that positive 1 goes here, negative 2 goes here. I can check this with FOIL. Here would be 3y. Here would be minus 2y. And that takes me back to that intended value of y right there. So I know that this here would be the answer. Okay. Now on some, the GCF will be a variable, or it could be a number and a variable combination. Number 9, for example, 6, 11, and 10 aren't all divisible by the same quantity, but they all have an x to give. So my GCF on this one would be an x. So then we'd have 6x squared minus 11x minus a 10. And that's what I'll be looking to factor, where I leave the x on the outside. Now for this one, I'm not sure if it's going to be 6x and 2x. Start over. Splitting this 6x squared. Could be 6x and 1x, or it could be 2x and 3x. I'm just going to check 2x and 3x first, as just a guess. And then I need factors of 10, which will be 2 and 5, or 1 and 10, where one of them needs to be negative. So I'm going to look through our various combinations here. All right, so after some thought, you'll see here that I need a negative 5 and a positive 2, so that I get here 4x minus 15x to reach that value of a negative 11x that I was looking for. So I know that this here is my answer. The bottom portion of this page, solve each equation by factoring. Same concept as up above. Look for a GCF. This one's 5. So we'll have 3y squared minus 10y plus 7. I need to factor this portion with that 5 out front. So I'll have 3y and y. And then I'm looking for factors of 7. And it's going to be positive, but I see it needs to add to negative, so it'll be double negative. So I'm going to do 7 and 1. This checks because I got negative 3, negative 7y, adding together to give me negative 10y. Now the solving part on this is the fact that we're equal to 0. So to finish solving, you set up both pieces equal to 0 and solve for y. On this one on the left, I'd add 7 to both sides and then divide by 3. On the right side, I'd add a 1 to both sides. And that is page 4. Page 5 should go much, much quicker. It's going to be special cases. So on these, we're going to be looking for perfect squares. Could have some GCFs in there, though. If you have 2 terms, very simple. You take the perfect square of the number with x squared, which is 1. So I'd have 1x and 1x. Take the square root of 25, which would be 5 and 5. And 1 needs to be positive and 1 needs to be negative. That way, when they multiply out, I get negative 5x and positive 5x to get me that invisible 0x there. So one like this, very simple. We'd have 3x plus 1, 3x minus 1. Okay, so you will see some that have 3 terms. And since these are on the special cases page, it's telling me to once again look for perfect square of this, perfect square of this. So I'd have x and 3, and then they'll both be negative to help me get that negative 6x. And this would factor down to, we'll simplify down to x minus 3 squared. On this one, same concept. Perfect square of 4a squared, 2a and 2a. Perfect square of 25, 5 and 5. I see that negative there is telling me to do double negative. This would simplify down to 2a minus 5 squared. Be on the lookout for a GCF. On this one, neither of them are perfect squares. You need to first factor out a 2, and then you'll see that you can do your x plus 6, x minus 6. Right? Bottom of the page, same concept as as previous page. You get it factored. X minus 8, x plus 8. You'd set up both pieces equal to 0. And you'd solve. So I get one answer as x is equal to 8 and x is equal to negative 8.